Hello everyone, my name is Stephanie Vasconcelos, and I am a member of the HLMSV group. Today I will present the Arduino code and electronic circuit for my tracking robot. I'll explain the code section by section, and then I'll demonstrate how the circuit works in the simulation. My robot is designed to help hospital staff locate misplaced medical equipment, avoid obstacles, and safely transport items to the hospital. Servo library. The first part of my code includes the servo library. This library allows the Arduino to control the servo motor. The servo motor represents the robotic arm of my tracking robot. The next line creates the servo object that controls the robotic arm. Pin definitions. In this section, I define all the pins used by my robot. The ultrasonic sensor is connected to pin 9 and 10. The servo motor is connected to pin 3. The LED is connected to pin 11. The buzzer is connected to pin 8. Pins 4 through 7 control the 2 DC motors. Finally, the potentiometer is connected to analog pin A0. Setup function. The setup function runs only once when the Arduino starts. Here, I configure all the input and output pins and initialize the servo motor. This prepares the robot before it starts its mission. Loop function. The loop function runs continuously while the robot is operating. Everything the robot does happens inside this function. Ultrasonic sensor. First, the ultrasonic sensor measures the distance in front of the robot. The robot uses this information to detect obstacles while navigating through the hospital. DC motors. After measuring the distance, the coder controls the 2 DC motors. These motors move the robot through the hospital while searching for misplaced medical equipment. Obstacle detection. If the robot detects an obstacle with 20 centimeters, it changes direction to avoid a collision. At the same time, the buzzer turns on to alert nervy hospital staff. Potentiometer. The potentiometer simulates the robot identifying the requested medical equipment. LED. When equipment is found, the LED turns on to indicate that the robot has successfully located the requested item. Servo motor. Finally, the servo motor rotates to represent the robotic arm, picking up the equipment and placing it into the storage basket. After completing the task, the arm returns to its starting position. Delay. Finally, the delay function allows the robot to complete each action before repeating the process. Now, I will demonstrate how my tracking robot works. This is the Arduino Uno. It is the brain of my robot. It executes the program and controls all the electronic components. Breadboard. It provides temporary electrical connections between all the components without requiring soldering. Ultrasonic sensor measures the distance to near obstacles, allowing the robot to detect objects and navigate safely through the hospital. This is the potentiometer. In the simulation, it represents the item recognition system. Adjusting it simulates the robot identifying the requested medical equipment. L293D motor driver. It receives commands from the Arduino and controls the direction and movement of the 2 DC motors. These 2 DC motors represents the wheels of my tracking robot and allow it to move through the hospital. Micro servo motor. It represents the robotic arms that picks up the requested medical equipment and places it into the storage basket. LED lights up to indicate that the robot has successfully found the requested medical equipment. Resistor limits the electrical current flowing through the LED, protecting it from damage. Piezo buzzer provides an audible alert whenever the robot detects an obstacle. This project demonstrates how Arduino programming, sensors, motors, and actuators work together to create a hospital tracking robot capable of navigating safely, detecting obstacles, locating misplaced medical equipment, and assisting hospital staff. Thank you so much for watching my presentation.